One of the things we spoke about in our last class was artificial lighting or scientific lighting, where an object or specimen, in the case of botanical art, is lit from a specific vantage point. And that point is to have the light source in your mind coming over your left shoulder at about 11 o'clock. And if you look at this cube in this video, that's exactly the way I've set it up. So you can see that if the light comes in from this angle here, then the brightest section of, or where the light hits the strongest, is the top of this cube. The next brightest area will be on the left-hand side because it almost faces the light source. So it will be your next lightest area. And then the surface that gets the light the least, because of the way the angle of the beams hit the surface of this will be your darkest area. And you can see the shadow. If you were to draw a straight line following back, the shadow doesn't exactly follow the line, the baseline of the cube, but it actually comes in at about 30% angle to the structure of this image. And you'll also notice that the shadow is quite short because of that 11 o'clock angle. Now I'm going to replace this with a cylinder. Now again, you will notice that the highlight is on the top, the strongest light is on the top, but then you also have a very light area off to the left-hand side, not right in the middle, but off to the left-hand side, and then it gradually, as the cylinder moves away from the light, you will get less light and therefore more shadow. You'll notice that again on the right side you will have a slightly lighter shadow, and on the left side you'll have a much stronger shadow. Now you can see, because of this white paper in here, you see a little bit of reflected light on this surface. So the darkest dark, even though this is dark all the way to the edge, the darkest dark is set in a little bit from that edge in order to accommodate the reflection from the table surface. So that's how it looks with a cube, with a cylinder. Now the lighting on the cone is just slightly different because of the fact that we don't have perfectly vertical or horizontal planes. We are dealing with a shape that it tapers to a point, and therefore, because of the angle of the taper, it gets a little bit more direct light from our light source. Again, our right side will always be much darker because that side is farther away from the vantage point of the light. And you'll notice that the shadow tapers along with the cone itself, so that you have a wider shadow at the bottom and it gradually tapers up to a very narrow shadow at the point of the cone. And that is something to be conscious of as you are shading a cone type shape. Also, with the cast shadow, you'll notice that if we were to draw a tangent line along the bottom edge of the cone, the shadow actually goes back even further than the original 30% a principle that we've used for the cylinder and the cube. So, and that's because, again, this taper causes the shadow to also taper back to a point at somewhere on the shadow, and you don't get You get a more extreme angle on the shadow as it travels away from you. So that's the cone. Now let's look at a sphere. Here's your sphere. What you will notice is because of its round surface, and we talked about this in class, that you have to think about the direction of the movement of that surface, just like there are latitude lines on a globe. Your color follows kind of the curvature of the sphere itself. And you'll notice that, again, we have our darkest shadow on the right-hand side, a lighter shadow on the left-hand side, all of which, even from the top, tapers to the highlight, which is in the upper left-hand quadrant, right in this area. You can really see it. Now, again, with the sphere, we will have some reflected light, and you can kind of see it right along this edge, so that the darkest shadow on this sphere is inside the edge. But the highlight is probably no lighter than the shadow on the left side. It's because of the reflection on the surface. And interestingly enough, if you will look at the cast shadow, you will see some of the cast shadow on the underside of the sphere. And that is because the light is hitting this sphere and is being blocked by the widest diameter of the sphere. And therefore, as the sphere goes around and underneath, in order to create that roundness, that wide diameter also gives you a cast shadow. So you will see that right along this bottom edge. And then the sphere will also follow around to define the shadow that the entire sphere is causing on the reflected or on the surface of the table. So that's your sphere.